Guys, hi, Praveen here. Welcome to an introduction session in AI and machine learning. This is the first session it's actually an intro session for everybody. So today, what we'll be doing is we'll be having, except the instructor, so everybody's on mute by default. You can ask questions on chat, and so the recording and the slides will be shared with everyone. You can we and so we will be sending forms. Please fill up the forms so that we can send you the details. We can send you the slides and the link to the video later. Okay, so this I'll just set the mood or the agenda for today. So the agenda is this is a discussion of the deep learning specialization course. Again, this is an open session, so everybody is here. We would be doing this session again next week with our candidates only. Today it's only me who's presenting. Next week we'll have the other instructors, including the professors from IIT Roorkee, in this lecture. To begin with, I will talk about IIT Roorkee, about CloudxLab, about CloudxLab, and about the course. I will also talk about the speakers and the instructors who are giving it. We will then discuss what is machine learning, what is the machine learning approach. We'll discuss what is AI. What is AI? We'll have Q&As. So the way the Q&A will be done is that you can ask me questions on chat, and I will be answering them. Okay. So just give me hold on. Okay, so we would have a break in the middle. It would be approximately about 9:30. It would be a 10-minute break, and then we'll come back to continue the remaining part of the lecture. Okay. Okay, give me a second. We would also be talking about different machine learning types, the neural network introduction, and Q&As. Okay. Okay, so we'll start with about IIT Roorkee, our partner in the in giving this course. So IIT Roorkee is the second oldest technical institution of Asia. It was formerly called the University of Roorkee and Thompson College of Civil Engineering. So it started off as a civil engineering in 1847, established by the British to set up the infrastructure in the country for the dams and the roads. Over a period of time, it's expanded and eventually has become a IIT. IIT, I think, a few years ago. You can get more details about IIT Roorkee in the link given here. Okay, so I'll tell you about a little bit of the instructors and authors. So these are the instructors and authors from IIT Roorkee. We have Professor Gaurav Dikshit. He's an assistant professor at IIT Roorkee. So he has been around. So he's got experience across industry, where he worked at Hewlett Packard, the Sharda Group. He's got a PhD from IIM Indore. His BTech was from IIT BHU. And a PhD from IIM Indore. So for the last few years, he's been working as an assistant professor at IIT Roorkee. He would be doing, so his specialization is AI, ML, and data sciences. The other professor from IIT Roorkee is Professor Raksha Sharma. She's also a assistant professor at IIT Roorkee. She's done a PhD from IIT Bombay, and she's also worked in industry and academia. She's also been a research at the Tata Innovation Lab at Pune. Her specialization is natural language processing and applications of machine engineering. Okay. Okay. Now these are the instructors from IIT from CloudxLab. So Sandeep Giri is the founder of CloudxLab. He's an alumnus of IIT Roorkee, and the reason what binds IIT Roorkee with CloudxLab, he's been teaching for the last 5 years. Before that, he's been at Amazon in Moby D shop, and has previously run another company, another startup. The other co-founder of CloudxLab is Abhinav Singh. His experiences are primarily he's got a lot of experience within the edtech. He's previously worked for Byju's and Hashcube before starting CloudxLab.com. He's an expert at AI ML, and he's also visiting faculty at SEA MHRD. So that's about it. Okay, the guy in the middle, that's me, Praveen. So I'm your host for today, and I'm currently the CTO and co-founder of Yatis Telematics. So I graduated from IIT Bombay with a dual degree, which gave me a bachelor's and a master's in electrical engineering. Post that, I worked at Philips Semiconductors in the Netherlands. So my experience with machine learning started there, where I was using machine learning along with electrical engineering to figure out what are the problems the factory and how they affect chips, ICs. So that's how it started. My work resulted in multiple patents and a few conference papers. Over a period of time, I moved to India and ran a management job at Cypress Semiconductors. So a few years ago, I started this company called Yatis Telematics. We do IoT, especially for vehicles. We also do, we're doing IoT for vehicles and video analytics. My interests lie in ML, computer vision, especially on the edge. So that's a bit about me. About the course. So the course is a certificate course in AI and deep learning along with IIT Roorkee. Right. So the course is a certificate course on AI and deep learning along with IIT Roorkee. We've you got to learn Python, NumPy, Pandas, TensorFlow, Keras. The specialization we got to focus more on deep learning, but as a part of deep learning, we will cover components of machine learning and we also provide a lot of prerequisites like Python, NumPy, Pandas in some of our as video courses, which is also available. We'll be again. So what's unique about this course is we combine faculty, and we provide and industry. So we do both of them, and so this is a great course. Besides that, I'll give you an outline of the course. So this is what the course looks like. There are a few self-paced classes for everyone, which includes machine learning. I presume this is okay. Okay, this seems to be solved now. We'll just continue. Apologies for the technical issues which we've had. We'll be just continuing now from where we stopped. So as I mentioned, this lecture is on the introduction to machine learning and deep learning. We will continue with this talk now. Okay, the certificate course of IIT Roorkee, we will be covering TensorFlow, Python, Keras, NumPy and Pandas and scikit-learn as a part of this presentation, as a part of this course. We'll talk more in detail about different sections later down. Okay, so we will so at the end of this course, you will get a certificate that looks like this. So whoever takes up the course will look like this. You will have your name on this, and it's basically a certificate that's from IIT Roorkee and CloudxLab, and will be signed by by members from IIT Roorkee's e-learning center and by Sandeep. Okay, so what's CloudxLab? CloudxLab aims to make learning fun and for life. We use videos, there are quizzes, there are hands-ons and projects to make and case studies. So the whole idea is to make learning a wholesome exercise, not just boring, just lectures, and has all of it. Okay. And yeah, so we just use real life use cases, and it makes learning fun, interactive and relevant, most importantly. Okay, so CloudxLab also has has a playground. This is what makes CloudxLab unique. So I'll just give you CloudxLab. So what it has is it's got so if you ever log into CloudxLab, and I recommend that you look at CloudxLab. Even if you get started, you get 15 days of the lab free, so you can start and work with it. So if you log into it, you'll get two sections: a playground and a content section. Okay, so in the content section, you'll get instructions, you'll get questions, answers, etc. You'll get instructions. You may have slides, you may have videos, and on the right side you got a playground. Okay, so in the playground you can type in code, and you can see how the code runs. So once the code runs and is successful, you can submit the answer, and what you get below is you get feedback whether your answer was correct or wrong. Okay, that's good. So CloudxLab is an online cloud-based lab. So in the cloud-based lab, you get pre-installed tools and software for practicing AI, machine learning, deep learning, data sciences. So the advantage here is that you don't have to spend time say installing software, etc. You can just come and get started immediately. So we take care of, there are multiple tools from in big data like Hadoop, Spark, etc. that are supported. As a part of AI and machine learning, we provide support both TensorFlow 2 and TensorFlow 1 TensorFlow 1 based environments. So it's like one place you can get started. So what you get, so this is an example of how it looks. This is an SSH, so you can just log in with SSH and you get a screen like this. You can click Python and run items over there. Okay, so again, summarizing what's CloudxLab, we aim to give a there's a seamless experience, no endless downloading or installations. There's no hardware, no permissions or you can set up your central setup. So there's a central database which has a lot of data which you can take directly. Otherwise, if you got your own data sets, that you can upload it directly, and you can play with your data. That you can experiment with what you've learned, reinforce whatever you've learned. The other nice thing, as I said before, you can log in from any device, anywhere. Like you could just, what we need is a browser, or you could do SSH. So any browser on any system, a Mac, a Windows, a Linux system, doesn't matter. You can just log in and get started immediately. Okay. Okay, so I'm just going to answer a few questions now. So there's one question is from there's a question from Shantanu who says, can we SSH to a lab from our own systems? Yes, you can SSH from your lab from your own systems. There's a question. Upload session. Okay, there were a few issues about the tech issues which we've kind of resolved now. There's a question on if this is access to CloudxLab paid. You can start up. So CloudxLab, we have a bunch of free courses, so which you can do for free. The lab is, you'll get 15 days of access free. So, and after that it is paid. So then you can take a look. You'll have to pay for it later. Okay. There's a question on what level from Charul Srivastav on what level of programming is required. So for the IITR course, we actually have a small entrance test which requires a certain level of programming experience. If you're a complete noob, this course is not for you. You can look at one of our deep our machine learning sciences course or a data science specialization courses, which we help people. Which will help people even who are starters or who don't have much experience with coding to get started. Okay, then Kester Yo has asked, how do we get access to the presentation slides? Presentation slides will be available. So there is a form below. You just have to fill the form. We will send the presentation slides. We will send you the presentation slides. Some more questions. Which programming language will be used? We will be using Python. So all this course will be in Python completely. Vivid Garg, okay. Then Mohit Khatri is, are there any prerequisites to complete the self-paced courses before each live session? The prerequisites are for people who don't have much experience with ML or with statistics or Linux. So in case you want to brush up certain skills, that's a good place to get brushed up, because once a course starts, it can go a little fast. And so if you think you need some if you think you need to brush up your skills, that's a great way to brush up your skills. We would recommend that you take a look at it, and then you can choose which content is interesting for you or relevant to you. Okay, so there's a section on Git also. So a lot of people we found in our batch one, they didn't have experience with Git. So we have a section on Git which you can take a look at, which also does that. Okay, Nikunj Patel has said, I've enrolled for the course. How is the live classes attendance captured? Well, there's a Google form. We'll send Google form and we'll send it to you. So Jaspreet Bhatia has asked for the machine learning, deep learning would be using TensorFlow. Yes, we'll be using TensorFlow to specialize more precisely, especially for the deep learning component. So what TensorFlow 2 does is TensorFlow 2 lets us access a Keras API, which makes it a lot easier to work with. Okay, Ritu Mehta has asked, if an individual is new to Python and AI, would the course help? If you're completely new to Python or AI, take our machine learning specialization, not the take a machine learning specialization which is self-paced. The instructor-led course would not be the right one for you. Okay. So Ritu Mehta has asked, how interactive are the online sessions? We run it on Zoom on a smaller audience. So you can ask questions. They're primarily, you can ask during the questions, you can ask questions by, you have to type in the questions. Sometimes the instructor may let you speak, but post that we've got comments, you can set emails. We'll open up other forms of access for you with which you can ask questions directly. Sandipin asked, will you have recording of this? Yes, you will have a recording. You just need to sign up. Okay. Let us just, I'm just going to continue now, and we will again have a break after some time. I'd rather take the next set of questions. Okay. This is on go. I'll take some slides and then I'll take some lectures. Okay, this was what I said. Okay, so CloudxLab, I'll continue with CloudxLab. So what CloudxLab believes strongly is that you learn better when you learn with your peers. So we've got a method in which you can, there's a social angle to learning which we are trying to build on. So what you could do is you can check a leaderboard, for example, to see where you are against everybody. There's a comments section where you can interact with both the other people who are taking the course and with the instructors, with the TAs, etc., who will be supporting you. We have a discussion forum which is very active, and so you can post questions, get feedback from, again, your peers, and people who have done the course previously also will kind of interact with you there. So it's a great place to interact. It's just not learning by itself. There's a lot of interaction. We try to simulate certain parts of the classroom using these features. Okay. Okay, so CloudxLab also has hiring partners. We've got a dedicated job portal and a person who works on enabling. Who we've got a lot of companies whom we have partnered with, whom we share, and those jobs are shared. Those job openings are shared with our students. We also share our profiles with students with our hiring partners. We try to make it possible for people to get jobs, and it's worked in a lot of places. Okay, now we'll start. What is machine learning? So machine learning is a field of study that gives the computers the ability to learn without being explicitly programmed. Okay, this was stated by Arthur Samuel back in 1959. He's a professor at Dartmouth. So what does that mean? So I presume a lot of you have certain experience with coding. So in coding, typically what you do is you write down a program that for a particular function. It's very closely defined. Like for example, if it's a very starting one, maybe finding the square, finding the area of a circle, etc. So that the computer gets explicitly programmed to do something. What machine learning tried to do was try to be a little more flexible and creating an approach in which the computers can do more than what they just programmed for explicitly. Okay, so that was what was the aim of it. Now we will do this with an example, with a real use case, and we'll try to make it fun also. That's what we're trying to do, try to make it fun. Okay, the fun game is we start with the game. The game is Mario. Okay, so I presume a lot of you have played Mario, have seen it before. So Mario was this game made in the 1990s by Nintendo. So what Mario had a Italian plumber. His name was Mario, and who was stuck in Mushroom Kingdom. So the kingdom had mushrooms, and his aim was to save Princess Peach. And the princess, whose name was Princess Peach, he had a bunch of challenges, including these ugly tortoises who would try to kill him, and he had to save himself from that. At the same time, he would go around getting points, etc. So I presume you've played it and you won the witness. So how? And now what we'll show: can the computer also play the game and win? Okay, we'll see that. So actually, it is possible. We can actually automate this, and we will see a demo of that happening. So what happens is that we'll actually learn, the program can learn to play the game Mario. How does he do it? How does the program do it? The program observes the game and randomly presses keys. It presses keys and then it tries to maximize the score. So as you played Mario, it's got score. So what it does is it tries something and sees, was it good for me? Did my score improve, or did I get killed, or did I achieve an objective of finally winning Princess Peach? So he just looks at it and says he tries to maximize score. So this was done by so the guy behind, his name is Tim Murphy, I believe. He's the one who made this course or made this program. He's a PhD at CMU. Okay. So now we will see a demo of this actually happening. Here a second, the demo is loading. Okay, so now this is playing Mario. So when it starts, the Mario, as I said, it just randomly presses keys. So in the beginning, this guy is just randomly pressing keys and nothing is really happening. He doesn't know what's happening and he just dies of old age, runs out of time. Give it some more time. So day 2, it's now getting better. He's playing little like my small daughter, and he's getting a little better at it. He could avoid some of the roadblocks, some of the turtles, but it still gets stuck. It's not really got through there. Okay, a few more weeks and Mario's getting better. Yeah, he's getting faster, as you notice. He's much faster than before. He's able to go everywhere and he's able to take care of those evil turtles and keep proceeding. As you notice, do you think he'll jump this one? Does he jump? Does he jump? He jumps. So he's learned to cover more and more obstacles, as you see. Okay, so he's actually able to go through. He's able to play this game. Now, do you think this is the end of it? This isn't the end of it. Few more weeks and Mario is now really getting at it. Okay. So now what you're going to see is Mario actually getting much smarter. So Mario is actually going to. Okay, what did Mario do there? Okay, what did he do? So as he went there, you see him, he did this tiny drop step and managed to kill the turtle on the drop step in the air. So looks like a little bug in the code, but the program figured this out by just trying it multiple times. Okay, next we'll show Mario exploiting another bug. Now, notice what happened there. Okay, he should have fallen inside, but he didn't fall inside. He could avoid it. Okay, so this is Mario. So the program, it learned to play Mario, and it learned to play, actually I even learned to play other games without trying more programming, without doing additional programming. It did the same thing every time, randomly press keys, looked at the score, tried to maximize the score. Okay, tries to only maximize the score. That's what it did. And the same logic or the same methodology can be used to learn other games also. Okay, now this is a question. Now you have this program. Can it learn to play other programs like Pac-Man? So would it have to just write new rules? Do we have to write the program from the scratch again, or just hook it to a new program and let it play for a while? What do you think? So yeah, you write. You can just hook it up to a new game and let it play. That's what it does. Don't have to pre-program it, and so this is like we are achieving what the objectives of machine learning were, where it's doing. So this program is not explicitly just to play Mario. It is can be used to generically manage more games. Okay. So Pranav has answered correctly. Right. Now we can do the same for life. How do we do that? We have to gather data and solve multiple problems. We've got, and that's how we do it. Okay. Now, what are the problems? Okay. Now, the philosophy today is that we humans have always been trying to predict. So when we pre-humans sitting back in the savannas, the grasslands, staring up the night sky, they saw the stars, and they try to find patterns in the stars, and they try to find out whether those patterns made any sense. Eventually, they actually made sense. They could figure out seasons from the stars, and by predicting the seasons, they had a huge advantage. So by predicting seasons, they could figure out when to farm, how to farm, or when to harvest. They could figure out patterns of migration of animals which they could hunt. So this method of trying to gather data is really old for us. We've been doing it for a long time, and we've been using it to our advantage, and we're just getting better and better. And so as I said, all the industry, the entire industry is just all industries are just trying to predict. They're trying to gather data and trying to predict. Okay, I'm just going to take a break and I'm going to answer one question. Sandeepan Das asked, so what is the training set for teaching Mario? Well, the training set is actually the output of the game. So as I said, the program is basically just trying something, randomly presses buttons and reads the frames. So it's just reading the frame, and that is its training record. It's creating its training set. This is actually an example of reinforcement learning, where the program is creating the test. Okay. I'm just going to continue now. We will take more questions a little later after this section. Okay. Okay, so as I said, that all industries are trying to predict. So the manufacturing industry is trying to predict which products to produce, what are the processes to optimize, which machines can break down, what machines need predictive maintenance, what can we avoid, what is the price of the product, etc., etc. So what is it trying to do? It's trying to use data to maximize its profit. Okay, it's trying to either maximize its profits, increase its revenue, etc. It's got an objective. The agriculture industry is also trying to do the same thing. It's trying to use the data to figure which crops to grow, which crops can get me more money, what will the prices of the produce, how much should you price, what processes to follow. So it's trying to find the best fit for all these problems also. The healthcare industry, well, the healthcare industry is really in vogue in the times of COVID. It's also trying to predict. It's trying to predict the diseases based on symptoms. It's trying to figure out which drugs are effective. It's trying to figure out whether the pandemic can be stopped, how long it will take, when will it start leveling off. It's trying to figure this out. It's trying to figure out operating procedures that are most effective. It is trying to figure out algorithms which can look at X-rays and catch the existence of the disease quickly. So all this is going on right now. So every industry is trying to predict. It's trying to get data from multiple sources, all available sources, and trying to use that information to maximize its for an objective, increasing revenue, improving profits, reducing costs, etc. Okay. So we are right now living through what's called a machine learning tsunami. There are self-driving cars on the road. We've got another great example is Netflix movie recommendations. So Netflix or IMD or anybody, this is the business of recommending. It's trying to feed you more information, tries to figure out what you're reading, also what you're watching, how you're interacting with this, what the other people watch, and it tries to find patterns using all the data to recommend you more movies. Okay, so this is again Netflix also. So Netflix, they've got a motive. They want to increase engagement, give more interesting content, so that more and more people join and use the content. Okay. Okay. The other interesting one is again in the field of recommendations. Amazon or Flipkart, what it does is again tries to figure out what you do, so what you've bought, and based on what you've bought, it tries to figure out what else you can buy based on that information. It tries to make you buy something more. It's trying to figure out what can I show this particular person, that will increase the chances of the person buying something more based on the history of what that person has bought. Okay. Google search, actually, even all search today is largely is very influenced by machine learning. So all the search engine providers, they're figuring out patterns. They're figuring out what you like, what your tastes are, based on your browsing history, based on your search history, and it tries to make the most relevant search item. It tries to put that in the front so that you don't have to, so they can find what you need very quickly. So we are being impacted by machine learning in most aspects, in more aspects than you can imagine. Speech recognition via smartphone. It could be OK Google, it could be a Siri, or it could be it could be Alexa. So oddly, yeah, it could be Alexa. It could be Alexa. So this is NLP running, and it's again impacted R. So what happened is very interesting. When I said OK Google, on my phone, Google just picked up. It's weird. Okay, so how do we automatically solve problems? We solve problems by gathering data and then applying intelligence on it. Okay, gather data, apply intelligence. That's what it does. So how do you gather? So what is the process of gathering data? Can you just get random data and is that sufficient? No, it turns out it's not sufficient. Once you collect data, it comes from disparate sources, and a lot of times it's just not usable. So you need to go through a process of cleaning it before you can process it. That's a very important part of gathering data. A lot of machine learning, so people who have done it will tell you that you take more time on actually gathering and cleaning data than actually running machine learning on it or running algorithms on it. So the data collection part is actually takes a large amount of time getting it ready for your machine learning processes to run. Takes a lot of time. So, well, one of the big reasons that's become why AI has become so important is that there are just so many sources of getting data these days. Everybody's got a smartphone. Lots of people's got smartphones. We are always spending so much time with our devices. You can collect data. So besides that, there are lots of IoT devices like GPS in cars. Smoke sensors somewhere, video cameras, you see CCTV cameras are just proliferating all across us. All this information is getting gathered. So we're getting a lot of, so basically hardware is getting very, very cheap. That makes it easier for getting more and more data. We're also interacting every time with our phone, creating tweets, liking photos, sharing information. All this information is digitized and increasing the pool of data that's available. Then the other things driving up is connectivity is cheaper. There are more forms of connectivity that just enables us to get more data. And this large amounts of data gathering is what's enabling AI to do what it is. As you've seen before, the fundamentals of AI were getting defined way back in the 1950s, but now you just have the amount of data that you need to process it. Okay, now again in the process of data, the other concept is like as I said, that we're collecting humongous amounts of data. And sometimes if you can't just take this humongous amounts of data and load it on one computer, even if you have a 16 GB computer or a 32 GB computer, if you spare a lot of money, you can't process that kind of information. So what's needed is distributed big data engineering. So where you can leverage not one large computer, but a pool of smaller computers. Now there's a lot of advantages in learning using these pools of computers. So one example is that yes, the smaller computers are cheaper. So it's often easier to have multiple small computers than have a humongously large computer. The other advantage is that it becomes so if in a distributed is it's automatically robust. So if one of your nodes fall, it doesn't really destroy your entire system. The rest of the computers can take that load and keep it running. On the other hand, if you just had one computer, that one computer is down and your process is stopped. So it's a lot better to use a group of network computers that can interact with each other. There are technologies that enable that, like Hadoop and Spark, which is also covered in our course, not in this course, but there are other courses as a part of the as a part of CloudxLab, the big data specialization, which covers those technologies. Okay, we'll take some more questions. Okay, there's a question. Okay, so this bit unsent said that we also have a lot of processing power nowadays. That's correct. We will discuss that of how that's also bringing things. Sandipan Das asked, "What is the deadline to register for the course?" Well, Sandipan, we are running really close. The course is going to officially start next week, so we might take a few more entries. So if you are interested, I would say you get started on it. We've almost we've almost run out of space now. Mad Max asks, how is ML related with data sciences? Machine learning, again, as I said, data is the bedrock. Without data, there's no machine learning. So machine learning, can say, is a type of data science. It's a type of data science. It's a way of processing data. It's not, so ML is not equal to data science. ML is a type of data science. Okay, I think Ashwath and the CloudxLab, the other guys are helping you with a lot of questions, so that's great. I'm just going to continue then. Okay, there's a question, Cresta, do I need a good graphics card to train the data? Cresta, depends on the amount of data you're using. If you have large amounts of data, especially say images, whenever you're working with images, I've seen that a graphics card, a GPU, really makes a lot of difference, even at very early stages. But there are lots of other types of machine learning that you can do on a normal computer, especially at the stage of it. So Sandeep Das asks, can I call AI/ML a subset of data sciences? Yes, you can in some ways. Yes. Dhruv Mishra asks, how much space and memory can you use on lab? I think we have right now set a limit of 5 GB. And you almost get one dedicated CPU. We don't have a GPU, but you get that. Okay, Ashish Gupta is, how many students per batch? Well, we have over 70, almost 80 people who signed up, and so we're kind of close to the limit. So we might just let like 85 people get in, so 5 more people. Daman Tuli asks, do hackers use machine learning to find bugs in systems? Well, they could, yes, they could use that also. Anirudh had a question, what are the prerequisites to graduate from the course? So the prerequisites that are, I think this has been answered before. We have to cover about, there are a bunch of compulsory exercises that have to be done. You need to attend about 60% of the classes and cover at least about 6 of the projects. So if you do that, you can get the certificate. That is an end-to-end project. If you do that project, then we give you we mention the certificate that you have successfully completed the project also. Okay, what about the programming languages used in ML? So ML is not dependent on any programming language. So you can write it in multiple languages. There are even TensorFlow has APIs in multiple languages that you can use. It can be written in C++. It can be written in Java, JavaScript. Go. So there's no limitation to the language. So R is another language where it's MATLAB is also another language where people use a lot of which is used. We use Python. So most of the world today uses Python for data science for data sciences and for machine learning. And so we would be using Python for the course. And if people are looking to trying to figure out which if you're trying to build out a career in machine learning, I would recommend Python unless you're in the embedded space where you might be okay with say C or C++ or System C, depending on that. But otherwise, if you are doing going for conventional, if you're machine learning, most of the libraries, APIs, etc., are written in Python. So okay, Mad Marks again. This is a repeated question. ML. So ML. I'd mentioned that ML is actually can be considered to be a part of data sciences. We have. So we've got. We've using a book. So we will send you. We will send you a link about. We put a link about the book which which we are using for this course. It's a book by a guy called Aureline. It's called it's a book. It's an O'Reilly book. We will share the link with you. Ratubata, would the course cover TensorFlow, Hadoop? It does not cover Hadoop. This is a deep learning specialization course. We'll be using TensorFlow, but not Hadoop. So again, Sandeepan Das, we'll be using Python only. We would be the entire course. We'd be just using Python. Okay. So ML, so this question again, a lot of courses on ML and data sciences. So a lot of our data engineering courses actually cover more aspects of big data also, like Hadoop and Spark, etc., which is not a part of ML. So that's the big difference between the data sciences courses and the ML courses what we have. So the data sciences courses also focus a lot on how to process large amounts of data on distributed computing. The machine learning specializations or the deep learning specialization doesn't look at that. It just looks at how it just looks at the machine learning algorithms more than this. So that's the difference between big data. Okay, there's some question. Okay, there's some question. Do I need any specific kind of hardware for the course? Will a MacBook 2012 laptop be enough? Yeah, it's enough actually. So the amount of for what is required for the course, the CloudxLab labs are enough. Whatever we provide in the lab is sufficient. If you want to do lots more things by yourself, you can do it off your computer. But the lab we provide will be sufficient to do the course. It's not, again, as I said, it's a lab that's made mainly for training. So you can't do production level stuff, but you have enough computing power to do most of this course. Sujit Kumar asks, is the knowledge of MATLAB necessary for data sciences ML? No, it's not. Unless you're really writing the code in MATLAB, you don't need MATLAB. Okay, Albie Smiles asks, how does this course differ from the free learning content? So we've got free learning content. So the free learning content, you don't get access to the lab. Okay. The second part is that the what we covering here in this course, we'll be using TensorFlow 2 with the Keras API. Our self-paced courses use TensorFlow 1. So TensorFlow 2 is as obviously the newer, the more advanced tool set. So we'll be covering that. That's one big difference. Yeah, that's one of the bigger differences, and other than the certification sector that you mentioned. So the question is, how does this course help us for jobs? Can we get recommended positions in associated companies with IITR? We cannot promise you IITR, but CloudxLab, yes, we have a lot of association with a bunch of companies we can help you get introductions there. We will help there. Prashant asks, will LLP be covered? NLP, that's natural language processing. Yes, we will also cover natural language processing. There's a lot of questions. There's some questions on math. So there is a certain level of math. All the level of all math you need for this course will be taught in this course. One part of the course which will be very unique. We will actually show how that you don't really need to learn very advanced mathematics. You don't need to know advanced calculus, etc. to do machine learning. We will actually have a session in which we will show just using BODMAS and Python, we can do backpropagation and gradient descent, which is considered to be the core mathematical concepts of deep learning. And that's a part of the class which will be covered later. Okay. Dhruv Mishra asked, earlier course was 2.5 months. Now it's 4 months. Dhruv, yeah, what has happened is as we ran course 1, we realized that we had planned a very aggressive schedule. So we needed more time than we had earlier anticipated. So that's what expanded the course. We realized that we had to add more sections on certain topics to make it clear for our students. So yes, so when we started, we thought we could finish it in 2.5 months, but we realized that 2.5 months is not sufficient for a course that is so broad and so deep. Okay, there's a question of how to integrate MATLAB to ML. Well, again, this is not specific to MATLAB, but you'll have to look at a course that's or content that's specific to MATLAB. Yes, you can do MATLAB and ML, but we're not going to be covering this in this session. So Sujit Kumar says that is AI predictions, derivations, or probability. Yes, probability theory is a part of it. We would be covering some amount of or the required amount of mathematics, as I said, but we won't be covering probability theory in detail for this class. It's not needed, as you will see. Rakesh Puril asks, isn't the industry looking for machine learning than deep learning? Rakesh, that is not true. So if in case you're looking like concepts of computer vision and NLP, they are largely dependent on deep learning. Traditional machine learning kind of breaks down there. Amit Khedkar asks whether the course will have lifetime access. You'll have content. Yes, you'll have lifetime access to the course content, not the lab. Well, if you want more access to the lab, you can extend that, or you can buy more lecture lab. But you'll get access to the course content. More. Okay, so some of these lectures some of the questions are being covered later. So I'll just continue with the rest of the presentation, and we'll again do the same thing. We'll take breaks and we will answer questions. Okay, now we're going to give you an example of intelligence which is possible with traditional programming and how we do it with ML. So now let's take a problem that affects us all, a spam filter. So spam filter, so what do we do in a spam filter? In a spam filter, any email that comes in, we try to break that, identify whether the email is spam. If spam is anything you're not interested in, random stuff it's random people sell to you, and anything that's not spam is called ham. Okay, so now what's the traditional approach? In the traditional approach, you first study the problem. Okay, you study the problem. You study the problem, you basically write rules, you evaluate how it's running, you check the errors. So if you're happy with it, then you launch it, else you just keep doing this, running this iteration and keep getting better till to a point where you become happy, where you get a happy face and you evaluate and you say, hey, this is good for me. Okay, now how's the traditional approach? In the traditional approach, you would look into the subject or email body, and say you would look for certain tags like credit card, free or amazing. These are certain rules which we say that which are kind of hallmarks of a spam. That's one way of looking at it. Okay, this is one way of looking at of trying to build a spam filter. Other way of looking, so you can have, so in other ways you can say that, okay, I have got this big data set of people who send me spam, a bit like Truecaller, for example, that looks up the person's address, this place where it's coming from, and highlights whether it's a spam. And just if it comes from from these addresses, just send it. It's spammed. I don't want to see it. So after you studied the problem, you've identified patterns, you write rules to do this. So again, so you have these incoming rules, incoming emails which are subject to multiple rules, and these are what you could call spam filter rules. If you've actually worked with Google Gmail, you can actually write some rules by yourself, simple rules. So rule that, so anytime that breaks a rule, it throws the email to spam. If it's not spam, then it's ham, and it goes to your inbox, safe stuff which you can read. And then there's an evaluation approach. So now what is the problems with the traditional approach? So the big problem with the traditional approach is that the rule set just keeps increasing. Number of people, number of ways you want to, what people find spam, the way people find find the kind of amount of material that's sent in spam is just increasing, and so the number of ways, the rules to identify a complete spam set is just increasing. It's just larger and larger. So assume that you've done this. Okay, so you had this rule set that said that, hey, if I find the word amazing, just throw it in spam. But what happens is that some smart spammer somewhere just figures this out, that you're just filtering everything called amazing. So he or she just replaces amazing with the word fantastic, and that kind of beats your spam filter, and you start seeing spamming. So what you enter an arms race, where you have to keep writing more rules, and the spammers are trying to ways of subverting those rules and finding ways to get into your inbox. Now, how would a spam filter be written in the ML approach? So when you're doing ML, so in ML, what we do is we just change. So instead of writing rules, what we do is we get data, and we train ML algorithms with the data. So where is the data coming from? The data is coming from you. So every time you mark out things that this is spam, the email provider, it just puts that, okay, this is spam. It just marks it out. It's labeled, this is a spam email, and the data set just keeps increasing. So the data set is there, and there are a bunch of ML algorithms that are trying to figure out patterns. It just tries to figure out patterns and not rules. Tries to figure the patterns that cause spam, which could be multiple aspects. Okay, so yeah, so that's the big difference between traditional spam filters and the ML approach. Now, one of the reasons why ML approach works better is, as you see, it's flexible. It can learn by itself. It figures out new patterns. So if the spammer creates a new pattern or goes to a new address, it quickly catches up. You don't need an army of engineers that just keep reading the data and keep figuring out what new rule sets to put in to catch the new scams. Okay, so so what happened? So now what happened? So what do you think? Do you think it's cheaper to run a spam filter with the traditional approach or with the ML approach? So it turns out cheaper to run with the ML approach, and more effective also. So that's why you see very few spam filters today use rules. They might be using rules also, but it's largely ML today. Okay, now the next question is, what is AI? So artificial intelligence, or AI, is often called the intelligence exhibited by machines. Okay, so what is AI? Is a theory and development of computer systems to perform tasks that require human intelligence. So typically human intelligence, visual perception, or the words computer recognition, speech recognition, decision making, translation between languages. So now so this is getting a little more AI as compared to machine learning or more deeper learning. So these are the examples of the tasks. So these are human intelligence level tasks, like computer vision, understanding what other people are saying, trying to create, like translating Chinese to English, English to Hindi, French to English, etc. All this requires human intelligence, and that's what AI is able to do. So we've had, so in mythology and in fiction, we've always been thinking about these mechanical or creating intelligent creatures. Very famous, so Talos is in Greek mythology. And a very famous one is Frankenstein, which Mary Shelley wrote, where a person is created from dead bodies put together. We've been fascinated by the idea of creating things that can behave like human. Even today, a lot of science fiction, a lot of movies, etc., still work on that same idea, going from so I think, Terminator series, for example, that's a great example. So the term artificial intelligence was coined by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, again back in the 1950s. So as I mentioned, a lot of theory for artificial intelligence has been thought of quite early on. So as a part of what is AI, they spend more time thinking of what should AI machines do. So they defined AI machines should have it should have a few sub objectives. So some of the sub objectives would be perception. The machine should be able to perceive, should be able to do reasoning, should be able to navigation, like robots moving through, natural language processing, so able to converse easily with people, and able to represent knowledge, so having kind of getting an abstract idea about knowledge, about information. So that's sub objectives. So AI's job is to represent knowledge, understanding and classifying terms or things in the world, like what is a computer, what is a thought, what is a tool. So back a few, like I would say, even a decade earlier, I remember there were tools like Lisp that were created. So back when I was in IIT Bombay, I remember that people were saying that Lisp is this tool that AI will use, and AI will be created with Lisp. If I remember somebody telling me, if AI is ever created, it will be created with Lisp. Well, not it's not really been the case, but yes. Now let's look at examples of reasoning. So one example of reasoning is to be able to play games like chess, Go, Mario, etc. Try to prove geometry theorems. Try to look at patterns. Try to look at X-rays. Try to look at ECG patterns, etc. To diagnose diseases, which is something what humans do. They look at things and try to figure things out. The other option, we spoke about, another sub-objective was to navigate. So how to navigate in the real world, how to plan a route, can you locate a destination, how to pick a path, how to pick the shortest path, how to avoid obstacles, how to move. Waymo, Tesla, etc. are in this place. They're trying to figure out how to do automatic navigation. Even the Roombas, which are these robo vacuum cleaners, are trying to navigate within indoor spaces, just trying to clean up houses. So navigation, natural language processing, how to speak a language, how to understand a language, how to make sense out of a sentence. So again, so we've seen Siris and Alexas, etc. that are doing these things quite easily these days. Perception, well, this has been a very interesting thing for people. How do we see things in the real world? Sound, sight, touch, smell. This is a problem which people want AI to solve. Okay, so the last concept, they said that they believe that a concept of generalized intelligence could emerge. So if you finish the previous sub objectives, just the existence of these all blocks will be able to deliver generalized intelligence, what we consider more human, like emotional intelligence, creativity, reasoning, intuition, etc. This was the philosophy which people thought of. So AI can be thought as a end objective. Okay, an end objective that leverages a bunch of items like hardware, and so the hardware would be used to get data. They come from, as you mentioned, I gave you examples of robots, of IoTs, of sensors that are just collecting all this information. On the other side, you have software. So software, you have sometimes rule-based programming, which I showed is an example of traditional spam filters. And then you have machine learning, which is machine learning, and then you have deep learning, which is just a part of machine learning, a specialized part, which I'll show you examples of where deep learning comes into the picture. So it's a part of it, and artificial intelligence doesn't encompass all of it, but artificial intelligence could use some parts of rule-based programming, some parts of traditional software, some parts of machine learning, some amount of deep learning, depending upon the application you need. The data gathering would be done with the large amounts of sensors, the hardware, and in case you have robots, etc., then they would also be They would be actually be interacting. So the artificial intelligence systems would be getting data, processing it, and actually there would be real-time reactions to that if you have in those scenarios. Okay, now we're going to talk about types of machine learning. Okay, I'll just take some more questions. CloudX, do we cover hidden Markov models? Some part of Markov models is covered in will be covered in the sections on reinforcement learning. When can I expect a full schedule of courses, especially live classes? Webhub, you can connect with our support team at reachus@cloudxlab.com. They will send you the latest schedule as it is. Arush asks, will we have access to lab throughout the duration of the course? Yes, you'll have access throughout the duration of the course. You actually have it a little more than that. So you'll have the lab access throughout the course, and actually more than that. Avinash Saraswat asked for spam filters was NLP used. NLP is also used. NLP is also used today for spam filters. Anuradha had a special question: jobs and packages after this course. Well, that depends. With a spam filter, how does it analyze text, or does get? Again, Ritu, there would be a lot of different algorithms that would be used to manage text, which could be NLP. It could be just identifying patterns, etc. Okay. Will there be Damantuli asks, will there be any Kaggle hands-on this course? Yes, there are a few of our projects are actually taken from Kaggle. So we use Kaggle data sets also. It's a bunch of questions on the certificate. Rahel asks, is this video available after live session? Yes, there'll be a video. Albi Smiles, can this course be held for algo trading, for trading strategy and techniques? We actually, Albi, we have a small section on that in this part, but yes, this course teaches you the fundamentals of deep learning, and then you can use that to do anything after that. Okay, so you just have to understand the concepts, and it can be used. I have a few examples later. Okay. Okay. Okay, so again, so there's questions of Python versus others. We'll be focusing on Python. Again, you can implement machine learning in multiple languages, but here we'll be focusing on Python because that's what's most powerful. Shantanu, do we have to have a learning of probability and statistics to train ML models? Shantanu, you need some basic idea of probability and statistics to have an intuitive understanding, but to train machine models, typically somebody who's just training models doesn't really need to have a deep understanding of statistics. You need to have an idea of statistics, but you don't really, for just training, you really don't need to be a master in statistics or probability. Okay, Subhajit, ML versus DL, again, I'm explaining those types. Later in the course, we will be talking what is ML and what is deep learning. So right now I'm talking about different types of machine learning. Latter part we'll be talking about deep learning. So it will come to that. So, Satakshi Singh says, being a mathematician, what kind of machine learning is suitable for me for research purpose? So, Satakshi, if you're a mathematician, okay, there is, well, it depends on what you want to do. So, if you're an advanced mathematician, you could even make your own models. You could study your own models to for both for deep learning or for machine learning. So. The whole the whole world is free, so it depends on what you want to do. If you want to just go after the theory of machine learning, that's a model, that's something which you could do, being a which for which, if you have a strong mathematical background, you need that, that's something you could pursue. Or you could do applied machine learning, which is basically just analyzing data of different types. That's So somebody with a mathematical background does have an upper hand. uh, and if you want to really leverage your mathematical background, you can even go into the deep theoretical aspects of why models work, and try to even change models. That's something you could do. Debushish Mahapatra, do you teach underlying math? Yes, we will teach the basic underlying math. uh, there was a question, if we connect if we Avinash Saraswat asked, if we connect data logger with different machine from where we are taking data, then can we connect AI machine to do logger to do prediction and getting recommendation model? So the question is whether they can connect a data logger from a different machine to an AI machine and use that data to create a recommendation model. Yes, that works. So actually, in the machine learning types, I will talk about what that really means. Okay. Jimmy says no code or low code options. So Jimmy, so machine learning you have to have. So if you want to learn hands-on machine learning, you have to do code. You have to do code. If you're interested in a no code course, we have a course called AI for Everyone, which is meant for non-coders, which talks about the AI at a more abstract level. Talks about the concepts, but doesn't really have to do much coding. Jimmy wants to use ML and AI for NLP and text classification. Yes, you can do that. How does it help in Excel data of stock? Uh, so, Aksini Singh, Excel can be used for some basic data analytics, but if you want to do something deep, bigger, then you need ML. Basic Excel, it's difficult to do any high level of ML with Excel. You can do some real basic levels, but not high level stuff. Ketan Bhatt asks, are you going to set up a WhatsApp group for participants for active collaboration? Yes, for the people who've signed up for the course, there'll be a WhatsApp group for active collaboration. CloudxLab, so my channel asks, do you expect machines to conquer the world someday? Well, I'm not expecting uh, I'm not expecting Terminator to happen anytime soon. Don't have to worry. So basic statistics are self-paced, but advanced statistics will be taught in class. Yes, that's correct. Basic statistics are course. We would actually don't teach advanced statistics. So we will actually show you that you don't need advanced statistics for machine learning. We will show you the basic ideas of machine learning, the core concepts as gradient descent, that it can be done with BODMAS and simple Python. That will be done. We'll just use it. We'll just start assuming somebody knows BODMAS, like high school level stuff, and we will show that we will derive the most important, the most central components of machine learning and deep learning. Okay. Nutunjay asks, will you cover deployment of models on production? We have a section on that. Yes. So Albi Smile says, will there be support for projects? So Albi, yes, you can choose your own project, but you can choose. So there's a end-to-end project that's needed, which you can choose by yourself. But the project will be more for you to do, and there are some questions. We will definitely help you in that. Dhruv Mishra, any set of reference books apart from the classes? There is a book, and we will put it into the comment section of this. We will put it into the comments, the official comments for this section. So Ashwat, or can you just put the put a link to Aureline's book in the comment section, because it's come multiple times. Okay, so we will do that. We will be covering that in the text. Okay. Okay, now machine learning types. Okay, so we're talking about, everybody's asking what's machine learning, deep learning, etc. There are multiple. So we'll talk about machine. We're talking about machine learning right now. So machine learning has, we can subscribe machine. We can say that machine learning, there's three types of it. One that uses human supervision, other that learns incrementally, and the third component is how do they generalize. Okay, there are three types of it. We'll first look at human supervision. A human supervision means that there is a human involved in the picture, so it needs human so there's supervised. The first part is supervised machine learning. So supervised machine learning is whether or not the models are trained with human supervision. So human supervision. Okay. So what it means is that you basically get data that is identified as, say, so in case you're looking at, say, good and bad, so somebody has pre-classified the data as good and bad, and so that's what's that's what's supervised learning. We'll see what it's more. So supervised learning has two types. One is classification, another is regression. So what's classification? So in classification, the training data that we have, it will include the desired solutions called labels. So you have training data and you'll have the answers to it. So those answers are called labels, and we'll provide those labels. So a great example of that of classification is spam filter. It's a classification spam filter. So what we did for spam filter is that the users are providing, saying that this particular email is spam or it's not spam. Okay, so it's neatly classified. There are neat labels for the emails. For the training set, there are labels, very neat labels, which have been created largely by humans. So that's an example of supervised learning, and that's a way of that's also an example of classification. So spam filter is classification. You classify an incoming email as spam or ham. So again, yeah, so as I said, spam filter, it's trained on many examples of incoming email. So as I said, over a period of time, we have been marking email as spam and as ham. So each email is then so each email in the training set contains a label which is spam or ham, which is not spam. The models then learn to identify patterns to identify spam away from ham. Okay, so that's how that works. So this is an example of supervised learning and classification. Now, the other close concept on that is called regression. So in regression is identifying a value. So as we saw in classification, you just have, say, two output types, good or not. This is very simple. But in regression, you get a value. So you could have a bunch of parameters for a car, like for example the car model, the make, the year, the mileage driven. So for example, mileage driven, and based on that you come to a value of a car. It could be depending upon how much the car is. There are multiple parameters that go in there. So the way that happens is that you would have a lot of data from historical data that this car was of this type, it was built, it's this model, this year, it's driven so much, it's of type diesel, gas or diesel, etc. And the price is so much. So if you have a large data set with all that information, you can take that information and make a model. And then when you get a new instance, so a new car and you have the same parameters, you say, okay, I have a new car, the car type is X, is the make is this, the model is this, it was made in, say, 2015 and is driven 100,000 kilometers. What is the price of the car? Okay, so and then this model can predict the new value for it. That is regression. So can I say it? So the regression, you're predicting the price of a car based on a set of predictors. So mileage, age, brand, etc. So they are predictors. So you could say they're feature sets, and then we train the value. So to train the model, what we need is we need large examples of these cars. So we need a large data set which includes these predictors, which would be mileage, age, brand, etc., and labels, which are prices. Okay. So I presume you get that. Okay, what is so one of the big concept? If you're starting with this, you need to understand what are predators and what are labels. So in if you're for this particular example, like for example for cars or specifically used cars, items like mileage, age, brand, etc. are predators, and that is just one final label, that is a price. Okay, so that's the difference between a predictor and a price. So in the training set, what you would have is you would have a huge data set which covers all these, which will have like for this car, the mileage, age, brand, etc. so much, and the price is so much. That's the whole model. If you have this huge data set, you can train the model, and then to the model you can just give a new type of car, a new car that comes in, and it will, it'll give you the value of the car. So that's an example of regression. So as you see, the difference between regression and classification is in regression you are getting a value sometimes as opposed to just a simple label. Okay. Now there's been a question. So this is something I've done personally, which says stock trading. So this is some data which used on the NSE, that's the National Stock Exchange of India. So you can actually, if you go to the NSE website, you can get this information called PE ratios and PB ratios and dividend yields. You can get this information for historic data. You can get this, and you can also get the value of the index value at that particular date. Okay, so what I did is I actually built a model. I used that data to predict the returns from a stock based on the based on these ratios. So these are ratios which kind of indicate the value of the cost of the price. So now when I try to, so this is something I did in my personal time. So what I had is I had one of the features such as the price to earnings ratio on the x-axis and the dividend yield on the y-axis, and then I plotted the 2-year yield in different colors. So the yield after 2 years, so at a particular date, so in 2015, 1st of Jan, the price to earnings ratio was say 17 and the dividend yield was 1.5. And 2 years later, so that's in 2019, what was the price of, what was the new price? So that is the return I have. So I try to make a model. I try to make a model that used price to earnings ratios with dividend yield, and we put different sets. So we said if blue color data, that's so if my return is more than 20%, it's blue. If the return is is between 10 and 20, it's green. If it's between 0 and 10, it's yellow. And if it's less than 0, so that basically means I lost money after 2 years, then it is red. So when we see, when we put this data, we could see a pattern. We can see a pattern when the price to earnings ratios are very high, the dividend yields are low, we lose money. On the other hand, when the price to earnings ratios are low and the dividend yields are high, you have a good chance of making money in 2 years. And that is, you can see there's a certain patterns in it. So now what this shows, this is 2 examples. So now if I take a new value of price to earnings and dividend yield, and I try to predict if I try to predict what my return is going to be after 2 years, if I want a value, that would be regression. But if I just want to see whether it falls in the blue category, the green category, the yellow category, the red category, it would be a classification task. Okay. So that's, again, we're talking about 2 types of, so what I showed you today is an example of using machine learning and stock trading, not trading as more stock investing, long-term stock investing. Okay. The next example we're going to talk about is unsupervised learning as opposed to supervised learning. So the difference between, so in supervised learning, what we had is we had a data set which was neatly labeled. So we had, so as you know, spam classifier, we had spam and not spam. So here the data is not labeled, you just have data just thrown to you, and he says, show me a pattern. The system then tries to, so there is no human intervention here, and is just trying to find a pattern. Okay, so that is unsupervised learning. So you have a training set and there are no labels, it's just flat, no ideas there. And so one example of unsupervised learning is called clustering. Now what is clustering? Okay, there's a question. I thought recommendations were also part of supervised learning. Yes, recommendations is a mixture. It's a mixture actually. So now clustering. So clustering tries to detect group of similar visitors to your blog. So the problem is that, yeah, these are my, I say you have demographic information about the people who are visiting your blogs, and you want to partition that into different types. You want to see patterns in that. Okay, so that would be an example of unsupervised learning. Okay, so yeah, detect groups of similar visitors to your blog. So the training set is unlabeled. So what you do is you train the model with the training set to your clustering algorithm. At no point do we tell the algorithm which group does the visitor belong to. So it just finds the group without our help. Okay. So an example of clustering, post you run clustering, you might just figure out that 40% of visitors are comic lovers or read the blog in the evening. 20% of the visitors are sci-fi lovers and read the blog during weekends. So this information is actually used extensively in almost all online businesses, where people are trying to figure out what types of people are visiting their website. So this information then can be used for targeting the blog post for each group. Okay, so other example of so I'll just take a okay, I'll just finish the unsupervised learning section first. Another example of hierarchical clustering is to bring similar elements together. So one great example of that is in biology. Okay, so biology. So what you're trying to do is you're trying to build a tree. And so what happens to it when you run and do a hierarchical clustering, the nodes that are together start, nodes that are closer are similar. So what we have on the right side is an example of a few mammals. Okay, you have a few mammals here. So you could say the horse and the dog are closer to each other and they're more related to each other. You can see there's also a distance metric that defines the genetic distance between them. But this isn't genetic distance, this is actually just based on observations. So rat and mouse, subtle difference, but yeah, they are different and related. They're close to each other. The monkeys, chimps, and humans. Again, so monkey is a separate family. So you can notice that these patterns. So if you want to build patterns like these, or these are also called dendrograms. These can be built by hierarchical clustering. Okay, hierarchical clustering. One great way of using where unsupervised learning is used is in identifying, say, anomaly detection. It's used extensively in anomaly detection. So in case, so this an example of anomaly detection is fraud detection in credit cards. So you normally have a certain pattern for your credit card behavior, and so it's happened to me. So if I use my credit card for a large international transaction, sometimes I get a phone call from my bank asking me if this transaction was done by me. Why? Because it has a certain idea of what kind of transaction I do. It knows that, and if it finds a transaction that does not follow my normal pattern, it's an anomaly, and it could be a certain, it could probably be fraud. So these fraud detectors use unsupervised learning. Okay, now this is another example which we had used at YATIS. This was so what we had done is we had used speed and RPM. So at my as I said, I run an IoT company called YATIS Telematics, where we were studying engine patterns while driving. And so one of the big things you're trying to figure out is driving usage and fuel efficiency. Okay, so that's something we were using, we're trying to figure out. And just give me a second. Yeah, driving patterns and fuel efficiency. So we wanted to figure out what are the driving patterns that help fuel efficient behavior. So what we have here is, on one graph is the fuel efficiency versus speed. The speed is on the x-axis, the fuel efficiency is on the y-axis, and you can see certain patterns. So what we see a straight line. We see that in general the fuel efficiency increases as we increase speed, but then we see these 5 spikes. we see these five you can say leaves or five branches that come out of it. And similarly, when we put the speed and RPM on a graph where we have RPM on the y-axis and speed on the x-axis, we again see these lines, these spokes. So these spokes actually they basically mean gears. And what we could do is we could run unsupervised learning after post filtering and identify each gear separately using just speed and RPM information. Because speed and RPM information, we could identify which gears on what. And then when we plot the same, the fuel efficiency, uh, we plot fuel efficiency versus speed, in which the gears are identified separately. We could see a very clear pattern. So in the clear pattern, we see is that as we drive on a higher gear, the fuel efficiency increases. As we go on a higher gear, the fuel efficiency is increasing, and for every gear there is a certain space, there's a certain optimum speed, and beyond that optimum speed, the fuel efficiency decreases. So we kind of know that, we've been told that, but then we had data, but using this information we could identify the data. So we could say that for this vehicle, if you operate on gear 5 at 60 speed, you would get most efficiency. So we could build algorithms that did this for all kind of vehicles, for trucks, for buses, for cars, etc., using unsupervised learning. So you could use unsupervised. So here we use unsupervised learning to identify in driving behavior, in driving analysis. Okay, so there's some questions about robo vacuum cleaners. There are some robo vacuum cleaners that are using ML. I just read something of there are some robo vacuum cleaners that use ML. You can go online and search on it. You'll get some stuff. There are again, there are multiple ways in which you can implement some amount of artificial intelligence, and some of the robo algorithms, some of them are using parts of ML increasingly. So there was a little chatter on between people on robo vacuums. Well, there are some robo vacuums that use ML. As you mentioned, AI. That AI was one of the sub objectives of AI is navigation, and there are multiple ways in which navigation can be implemented. Some of it can be implemented with don't have to use DL and computer vision a lot of places, but increasingly there are robo vacuums that are using ML. Then there's a question about. Okay, there's a question whether the webinars are part of the course attendance. This webinar is actually an open session. It's not a part of the course attendance. We will be reconducting this particular introduction next week as in a section that's exclusive to the students of the IITR DLS course. That will be done again with it will be a smaller group, and the professors from IIT Roorkee will also be online then. It's a question of how much space is allocated to the participants on CloudxLab. We allocate 5 GB. Okay, Dr. Ritesh Divangan asks, algorithm using supervised and unsupervised learning is the same or different? They are different algorithms. There are different algorithms of supervised learning. There are very different algorithms for unsupervised learning. So yeah, they are different algorithms. Sujit Kumar asks, when will it be 4 months? Well, the online course is going to take, it's going to take a fair amount of time. We've counted it's at least around 80 hours. For classification, okay. KB asks, when is it better to use supervised versus unsupervised? Similarly, when is it better to use classification versus regression? Okay, so I think this is a good time I can go back and just kind of summarize on the types of machine learning. So when we stopped, what we did, we were we were talking about types of machine learning, and we were the types of machine learning that are that are separated by the human supervision, whether it needs. Okay, so there's one type is supervised machine learning. So in supervised machine learning, you need to have data that is labeled. So your output data, so in terms like the easiest example to look at that is the spam filter. So in terms of when you're doing a spam filter, you just have to specify data. Your algorithm has to finally figure out just whether the particular email is spam or not spam. So what it needs to do is it needs to classify incoming email as spam and not spam. So that's a classification task. Now to do that, the data set that's needed has to have has to so the training data set has to have cleanly labeled emails. So you need, say, a million emails in which 50% of them are marked as these are spam emails, and the rest 50% are marked as not spam emails. So the data set, the training set that comes in is supervised. As there has been supervisions being done, and the training set has been marked by typically by humans supervision. Another example of that could be computer vision, where in case you want to see whether a picture has cats or does not have cats, so you need a bunch of pictures which has cats, and where it's clearly labeled this picture has cats, and a second set of pictures which says this label these pictures don't have cats. After you have this information, a supervised algorithm can take this information and identify patterns and run classification. Okay, regression is used specifically when you want to have, say, let's have like regression is used specifically. Yeah, I'll take this simple example. Let's say you want to figure out the price of a car based on just one parameter on mileage. Okay, so when you want to figure a price of a car, you don't want to have you need a value. You want to say that the price is $1,000 or 10,000 rupees or 1 lakh rupees. You don't want to. You're not saying that the price, whether the price will be good or bad. You have to say that the price has to be X amount. The amount has to be. So there you need to do regression. You can't do classification there. Okay, so you can so when you want to find something like these, like price of something, your task is a regression task. It's not a classification task. Okay, then there were some other questions on unsupervised learning. Okay, so again, yeah, so when do you use unsupervised learning? You use unsupervised learning when your data set is, when you don't have, when you don't know what patterns you're supposed to find. Okay, like, so for the example, the real example I chose, where I just had data like this, and you're trying to figure out which first gear, second gear, third gear, fourth gear. We had an idea that now we just ran the algorithms and it figured out what the gears are. That's an example of unsupervised learning. We didn't tell them that, hey, this value is this gear, this value is this gear. We said that would be a supervised learning problem. Yeah, we said just give me 5 sets, because I know this car has 5 gears, so there should be 5 sets of data. Please identify those 5 sets. So that's an example of unsupervised learning. So whether you use unsupervised learning, supervised learning, or classification or regression is largely dependent on the problem you have. So a different problem would require a different algorithm. Okay, I presume that's clear. Albi Smiles asks, have you used ML to analyze the patterns of viewers for CloudxLab? Yes, we do that because we do run a lot of online advertising where we have to figure out targeting, etc. So this is like a daily exercise where we keep using machine learning tools, etc. Some from Google itself, to figure out what are the patterns of the people who are coming to our website and how to serve them better, and where to target, which people, what kind of information, what kind of courses people like. It's used extensively. Okay, is OCR supervised or unsupervised? Mrityunjay, a certain part of OCR So a lot of OCR is actually simple rules based, or doesn't. A large part of OCR actually doesn't require machine learning, does not need machine learning or deep learning. There are modern libraries that's using machine learning. So what typically is done in OCR is you use something like OpenCV that runs a bunch of filters to extract patterns, and sometimes those patterns are then fed and try and compared against known characters. So if you know it's English, you could compare it against an English data set and tries to figure out what matches. So in a lot of cases, so OCR was done conventionally before without machine learning. Now there are machine learning supervised algorithms that are used extensively. PyTesseract is an example of it. What is the example of using ML with Spark and ML with Python? So ML with Spark is used more for big data analysis also. You can use we'll be focusing on ML with Python right now. Okay, Avinash Saraswat, same session will be conducted. Yes, Avinash, the same session will be conducted exclusively for the people of the students of batch 2. It will include these professors from IIT Roorkee also. Yeah. So okay, next. Okay, I'm just going to continue now. We will again take a next set of questions. Next, okay. Now we were discussing reinforcement. I'm just gonna delete this slide. Okay, now so we will now. We will now discuss reinforcement learning. So reinforcement learning was the first example we gave in this lecture, the Mario example, where so the entire Mario learning, where you're learning the game, was actually an example of reinforcement learning. So what happens in reinforcement learning? The action is observe, set an action using a certain policy, run the action, get a reward or penalty, update the policy, and iterate till you get an optimal policy. So if you remember, the way that the computer figured to play Mario was by trying random keys. So it tried a certain set of keys and looked at what's happening. It was looking at the few frames, looking at points, etc., and figuring out what to do. It said that okay, doing this doesn't help. At some point, it would have a policy. Okay, let me go walk into those turtles. Let me see what happens. It sees that it died. Once it says, oh, the policy of walking into turtles is wrong. Let me try jumping on the turtles. Then next time it tried jumping on the turtles. When it jumped on the turtles, it saw that it survived and it got more points. So it says, yes, this is a strategy I need to do. I need to jump on turtles. If I see a turtle, I need to jump on it. So by trying these multiple strategies and multiple policies, it figured out so it looked at the points, it looked at the reward, it looked at if I survived. If it is, then it just kept updating the policies. So it kept doing the things that made it survive, that helped it survive longer and gave it more points. So it kept doing this till the best policy is found. So the machine learning, machine learning and reinforcement learning, what it does is that it observes the environment, it selects and performs a set of actions. Then it looks at whether it's being rewarded or whether it gets penalties, and then it iterates over the best strategy to get the most rewards over time. So it keeps trying this. So that's an example of reinforcement learning. So in reinforcement learning, you make a policy, you try it. If it works, it's good for you. If it doesn't work, it's not good for you. It updates its sets of policies and moves forward. Okay, so that's reinforcement learning. Okay, so one of the applications is, it's used by robots to figure out how to walk. DeepMind's AlphaGo was so the AlphaGo, which I think happened a few years ago, I think a couple of years ago, it defeated Lee Sedol at the game of Go. So this was an example of the DeepMind used reinforcement learning. So what it did. So what it did, it basically played this game multiple times, tried a lot of strategies, figured out patterns, etc., and eventually it figured out patterns that could beat the champion at the time, Lee Sedol. So what's interesting is that the computers could beat the world champion of chess in 1996 by not using, they used a more conventional way of playing. It basically did more brute force, where it just tried multiple. It just figured out what could happen, evaluated multiple scenarios, and did the first scenario. Whereas what while for DeepMind, for AlphaGo, what it preferred is that it actually played the game lots of times and started figuring out strategies to employ. So it was different. Okay, now the next type of machine learning is, does it learn incrementally or not incrementally? Now let's see what that means. In incrementally, it has one concept of increment learning is called batch learning. In batch learning, the data is fed to the system in batches. So usually the problem is that you cannot throw large amounts of data into an ML system. You need to break it up. If you break it up, it's kind of easier to manage. So you break it up into batches and then feed the entire data, but in batches to the algorithm. So the algorithm is now taking each batch, evaluating the solution, analyzing errors, and analyzing errors, running these algorithms. And once you reach a nice little state, when it's happy, it launches. Okay. So that's batch learning. So in batch learning, it's what can do. It can do offline learning. So you basically have all the data offline. You have you may have like several gigs of data. So if you're trying to train a machine learning algorithm on the entire ImageNet set, you will take the entire data and you will break it up and you will feed all the batches. Now, as I said, this is offline. It is incapable of learning incrementally. It needs to get all the data available, maybe in batches. And so here we are going to train all the data, but each data would be broken up into batches. That's about it. So again, so when we have the system, once the system is trained, you push it to, you're happy, and it runs in production. So it now keeps running, but it doesn't update anything. It's just running. The last trained algorithm is used every time. So whatever has been learned in the offline training process is used. There is no more training running. If you want to train anything again, you have to take the whole system offline and put the entire new batch into the system. That's how you do it. Okay, so now as I answered, what do you do in batch learning when you have new data? As we said before, the data cannot be trained incrementally. So we have to train the new system. You have to train the new system. So you have to take. So in case you've trained an algorithm, you have it online. It's been running, but what happens is that you get new sets of information, and you said, hey, this new set of information also has to be included in the algorithm. So what do you need to do? You actually have to take you have to train from scratch again. So you have to build a new data set and stop the whole system. So train the whole thing again, stop the whole system, and then replace it with the new algorithm. So that's what you need to do with batch learning. So as I said, the limitations of batch learning. So limitations of batch learning comes when you have to train the system with new data. So every time some new data is available, you have to go and do the entire training all from scratch. And if this data is huge, training just gets more and more difficult. It takes a long time, and a lot of times this is just not feasible. It just doesn't work. It's a showstopper in a lot of cases, as I said. So the other method is online learning. So in online learning, what you do is, yes, to start with, you have this old batch of old data. You take the entire data and you train the entire algorithm, and then you launch the solution. and then and it runs, and every time if the new data comes, it just runs, it just trains on the fly, it just trains incrementally on the new data, doesn't go back and integrates the whole thing together. So the advantages of the system, yes, the system trains incrementally, it just feeds the new data that comes in sequentially. It could be training in batches. So this system can train new data on the fly. So wherever so it's extremely good for data with systems where the data is continuous. So again, stock market is a great example. So if you create algorithms. So the high frequency traders, for example, this is one place they'll be using. So where they would be study. So if you get just new set of stock prices, it just feeds in. You don't stop the whole thing, go back, train everything from scratch. It just gets the new information and feeds into it, and the model just does minor updates to itself, and it keeps going forward. Okay. So now as I mentioned, now as obviously, so you can see why, and why online learning helps a huge data sets. So what happens when you have lots of data? You break it up into chop into multiple pieces. Some of these concepts is what's called big data, where you have the big data is essentially how to manage huge amounts of data with lots of small computers. So typically what you would do, you take the big data, you would break it up, and so divide and rule. That's a nice example here. So you take data, you break it up to small pieces, and then you feed into your training algorithm. This way the online system can handle new data. Every time it gets newer data, it can do that. So then the online data systems, nice things about it is that can be used to train huge amounts of data that cannot be fit into one machines. Now the training data is being divided into multiple batches, and the system is being trained on each batch incrementally. So that's some of the challenges of online learning, where you have just data coming internally. So a lot of times you've seen that the system performance gradually declines. It can happen. So sometimes it happens usually it happens when bad data is being fed. So now this bad data can come from, say, so in case you're running a predictive, if using IoT data, for example, if you're a malfunctioning sensor or robot, it'll keep feeding this wrong data, and the system just doesn't know the data is wrong, and it can slowly pollute the system, pollute the algorithm without you realizing that. It can also happen if somebody is spamming a system intentionally, say jamming, or there's intentional hacking of the system, etc. This can be a problem. So one of the big challenges in online monitoring is that it's not like you set it up and forget it. You can never forget it. It usually requires humans to look at it. It actually requires monitoring. So somebody needs, so it can run by itself, but if you let it run itself, it can go mad, it can go really bad. So somebody needs to keep monitoring and check if there's a performance drop, or have a system that monitors input data and removes anomalies. So all this is needed if you want to keep an online learning system running. Okay, right. So now we'll talk about we'll just take a few more questions. Okay, okay. Nirul Sharma asks how many live classes of the class. Anirudh, we expecting around I think more than 20, 25 right now, I think. We will share we will share the course plan with you, the way we know it now. Okay. Okay, I'll just continue now. Okay, now the next part is how do programs generalize? Okay, where that came from. We're going to talk about instance and model based learning. So a big part of the machine learning job of machine learning task of an algorithm is to make predictions. We spoke a lot about the requirement how different industries need to keep making predictions. So machine learning is largely used to build predictions, and so you need to have a good performance on the training data. But in the end, what really matters is how does it look, how does it perform on newer instances. So you get so the example we took, if you have a model that predicts the price of a car or possible, so when a new vehicle comes in, you need to see how it performs, what kind of prediction it gives, and how accurate that prediction is. So what a system needs to do is it needs to be able to generalize on the given examples, so that and use this generalized intelligence, you could say, in some ways, to analyze a piece of data it's never seen before. Okay, so it's yeah, can never see before. So now you're aware how do they generalize. Now we're going to talk about generalizing machine learning. Now there are two parts of it. Now we can talk about one part is called instance-based machine learning. Now say assume you have a machine learning. So you have this, you've got you have this set. Now for example, let's say that you have this set of data that says that of squares and triangles, for example. Okay, you got squares and triangles, and you have, that's your label set. You have said that okay, these are squares or triangles. Now you get this new instance called x. It's placed here. Now one way of looking at it is that of figuring out whether, now the problem is is this new instance a square or a triangle? Now, in an instance-based learning, what it does is that it looks up at the distance. It sees, okay, the new instance is actually close to two triangles and only close to one rectangle. So it is a triangle. So that's how the instance-based learning will go. So instance-based learning will take a new instance and it will try to compare against known instances and see what matches it closest. Okay. So one of the clearest formats of this, where you learn by heart, your system learns by heart, and then when you get a new piece of information, it tries to measure similarity. So what it's doing is, so as we saw before, a new piece of data, an x came in. Your task is whether is it a square or whether it's a triangle. So it just looked up, what am I close to? It says I'm close to two triangles. The x is close to two triangles and close to only one rectangle. So it is a triangle. This form of method is called instance-based learning, based on closeness and similarity. Okay, so some of the examples is the way the spam filter flags emails. So, for example, you know that these emails are identical to known spam emails, which is because it's been marked by other users. So these emails are. So the questions are: is it identical to known spam emails? Are the emails similar to known spam emails? So what is required is a measure of similarity between two emails. So you're going to take your incoming email and your old email and see what's the comparison. And a basic similarity between two emails can be count the number of words they have in common. This is like a simple test. So for example, if there's the same set of spam mail that's being sent over periods of time, you could have a simple count, like count the number of numbers. If the numbers exactly so much, then it's likely scam. This is like one of the examples. Okay. Now the other form of generalization is called model-based learning. So in model-based learning, what you have these instances of squares and triangles, and you have trained a machine learning model, and the machine learning model has looked at the data and figured out a pattern. So it's kind of figured out that okay, there is there is a difference between triangles and squares, and I can draw a line that kind of delineates these two types. Okay, the point is it says okay, so this would be a kind of this would be, say, a generalization. It would build a model and understanding that okay, there is actually a border between these two sets, and when I get a new instance, I won't check if it's closer to to triangles or to squares, I'll just check whether it's in this side of the boundary or whether that side of the boundary. Okay, so there's a difference. So in the instance-based checking, what you were doing is you were trying to compare similarity between closest instances. Here, what's been done is that the model has built an understanding of whether of what is the differentiation between the instances, between triangles and rectangles here, and it checks whether this particular instance fits in which side of the model. Is that clear? This question says model base isn't like clustering. Well, it's kind of, but it need not be clustering. Even supervised algorithms use this model extensively. Okay, so yeah, so now continuing on this way, another way of generalize. So this is another way of generalizing from a set of examples where we build a model with these examples and then use the model to make a prediction. This is called inference. Okay, and usually we figure out that this is that this model will work well. That is the whole idea. That's what we try to believe. We will be talking it later in more detail. Okay, so now this is a question which people had for a while. Artificial, so we're talking about deep learning. So artificial neural networks, ANNs. This is a specialized form of machine learning. Okay, so somebody was asking, can you explain model-based learning again? Okay, I'll just come again. Okay, so now, okay, so what we are trying to figure out between instance-based and model-based is, because there's been some questions about instance-based and model-based, so I'll just touch on it again. So the problem is that you've been given a training set which has, say, rectangles and triangles, for example. The whole question is that in future you won't get something that's exactly like a rectangle or exactly like a triangle. You get something that's different. And how does your model, so how do you say whether it is a rectangle or a triangle? Rectangle and triangle are just abstract ideas. So one way of doing that, so if you're doing instance-based learning, what you'll try to do is you'll take your new instance and try to compare it against your known set. So in this particular case, you're comparing, so your new instance is this X, and you're going to compare, is it similar to triangles or is it closer to rectangles? So if it's closer to triangles, it says the new instance is a triangle. So that is instance-based learning. So here it's comparing against specific instances. Whereas in a model-based learning, what it's doing is that, importantly, we take the data and we build a model. Okay, we build a model of these examples. That is it. So in instance-based learning, you're not building a model. But here you're building a model. And then you're using the model to make predictions. That's in machine learning. So you've built so now an example of the model could be that the model is a border. It figures a border. And it says, hey, this border is so I'm going to check if this new instance lies within the border or outside the border. If it's within the border, it's a triangle. And if it's outside the border, it's a rectangle. Okay, so here it doesn't check for closeness. So for example, in this case, this new instance could actually be close to 2 rectangles, but close to 1 triangle. But in model-based learning, it will say that, hey, but I don't care whether it's closer to 2 rectangles. I know there's a model, and according to the model, this new instance lies on this side of the border and therefore is a triangle. Okay. So some examples of instance-based learning, some of it is used in decision trees sometimes. This is an ML algorithm that is used sometimes. Okay, I'll just take a couple of more questions. Where does ML and R meet? So R is just another language like Python. So R is also used extensively in machine learning. As I've said a few times, R it's just another language of doing machine learning, and a lot of machine learning is also done on R. This is that we build Python is more popular, and there is more support from different platforms, etc., for Python than for R. So Ritu Mehta asked, spam was defined as a classification earlier. Now it's defined as an instance base. So Ritu, this is not. So again, the problem is spam filters. There are different ways of specifying it. So one method is classification. I just gave you an example of if you use instance-based, if you use an instance-based generalization, how a spam filter would work. I'm not saying that's the same thing. Right now, yes, we're using models and supervised learning for spam filters. I just gave an example how a spam filter could be done would have been done in the instance-based with an instance-based system. Okay, so now we'll just come to the interesting part, artificial neural networks. So what are artificial ANNs? So computing systems, well, we've always been inspired by biology and natural life for a lot of things. Dragonflies inspired helicopters, birds inspired planes, eyes inspired cameras, and biological neural networks. The neural networks that are in your brain have or in our brain, in animal brains, have inspired computing systems. So this is a fairly these kind of the ANNs actually have been taking over really fast, and has been a real revolution recently. So a lot of this understanding has been done. Well, so there have been parallels have been built based on neuroscientific studies on animal brains. So how a machine learning? So this is what a artificial neural network looks like. Okay, in the artificial neural network, what you have a bunch of these neurons. What do you call? These are called neurons, and each of these neurons are tied to other neurons. So let's just look at this case. So in this case, there is an input layer. So let's assume that in your input layer has like 5 parameters that are, or not 5, you have 6 parameters that are coming in, and they are then there is a mathematical relationship which is basically like a weighted mean, okay, that are calculated here in what's called a hidden layer. And this so what we see, so and then okay, let me just go step by step. So what we see really is from an external system, we'll see an input layer. So we will see the inputs, let's say in this case 6 inputs being applied to a system, and in the output we have say 4 output systems. Okay, that's how it's done. So like for example, this could be a classification system to say if the input has a cat, a dog, if it's a cat, a dog, a jackal, and a wolf, say for example. So you would feed in the input from this side, and if it's a cat, this layer, this particular vector would highlight and say, hey, this is a cat. Now that's how it's done. And so what happens over here in these systems is that this is not a circuit or something. Everything's put in software. So there are these so you have these input variables that are coming in, and what you have here, you're basically combining. So as you see, each input is then combined with these hidden layers, okay, and then each of these hidden layers are then combined for each output layer. And how are they combined? They are combined using weights. So what we are finding is weighted means of each of these layer of the previous layer. So so uj would be a weighted mean of the inputs, of all the inputs, and there would be different weights for each of these input layer neurons. Okay. Okay. So another good way of easier way, let's figure out, is that is an example. There's a more intuitive example. Is like in case you go to a hotel and you have hot water and cold water coming in. So and then you have a mixer in middle. Okay. So what you would need to do now, you have an optimum temperature. So the optimum temperature is basically a combination of hot water and cold water, and you would basically be so you would come, you would put it on, and then you would say, okay, if it's too hot, I would start taking it towards cold, and if it's too cold, I would be taking it towards hot. So what is really happening here is learning. This is like a simplest form of learning. This is what is implemented in deep learning. So these values, so it's like turning a it's basically like turning a knob. One input is your hot water, one output is your cold water. You know that you like to have temperature around so much, and you would keep adjusting the knob to get the optimum temperature. Okay. So what is deep learning? So in a simple neural network, you would basically just have, say, one layer between your input and output. Okay, so what you see from outside is just an input layer and an output layer. You don't see the internal layers. The internal layers are internal to the model which you have, and so those are called hidden layers. So in a simple neural network, you would just have, for example, one hidden layer, and in a deep neural network, you would have multiple of them. You would not have one, you would have to have a few of them. Okay, so that's what deep learning neural networks is, and that's what we would be studying in detail. We'd be seeing how to implement them, what are different configurations to implement them in, and what are the different applications, etc. Okay, now I'm just going to take a few questions. Okay, there's a question again. What programming language do you recommend for a beginner? We recommend Python. I say I would recommend Python. You're a beginner for data sciences, just start with Python. This is an important topic, most important topic. Do we have our own mobile app? Which can assist in learning? No, we don't have a mobile app. Our so CloudxLab is entirely on the net, so you can access it with any browser. Albi Smiles asks, is there a language that can take over Python in the AI area in near future? Well, in the near future, I don't think so, but there's been a lot of work running on Go, for example. I believe JavaScript can have a lot of interesting applications. For example, if there are niche applications, like for example, if you're writing an Android app and you want to use or AI or machine learning in an Android app, you'll be largely using Java or Kotlin. You won't be using Python. And similarly, if you're trying to implement this on tiny embedded systems, you're more likely to be using C. In general, I still think Python is what's here for strong, and still the mainstay. But hey, you don't know, in 5 years the landscape might just change completely. Okay, so machine learning is more questions. Okay. Okay, so machine learning is used extensively all across. Almost everyone uses it. We've discussed Pinterest, Google, Facebook. It's used by everyone anywhere. So some of the examples are Google Translate and Auto Draw. I would say that try these examples. You could try these AI experiments with Google. It's a nice place you can do this. Google Draw is interesting. You just draw a couple of doodles, and it kind of figures out what it most likely is. Okay, I'll just stick to some more questions on deep learning. Okay, Nikunj Patel asked how many hidden layers are there in deep learning, and how do we know it's optimal? Nikunj, there is no golden rule. So there can be, depending on the problem, depending upon the data you have, it can get very deep. In computer vision, for example, we have seen there are models that are more than 300 layers deep. So there are like more than 300, actually even more. I think some people have input 1,000 models with 1,000 hidden layers. So typically, if you make it uh, if you make it more deeper, sometimes you can see that you're getting deeper insights. But if you don't have much data, it doesn't help much. So if you have a lot of data, sometimes adding depth can help. But again, please note that, so if you can look at this, what you're noticing is that there are a lot of interactions, right? So as you keep increasing the number of hidden layers, there are just so much more connections, and notice each connection is a separate weight. So if you build a very, very large network, it becomes more and more cumbersome to use. It becomes very heavy. You need more computational resources, and sometimes you just cannot get it working. So arbitrarily changing the size of a neural net, of increasing layers, is not the right thing. True that that's the direction in which we're going right now, but still a lot of people try to figure out what is the best architecture. So for different so there is no golden, there is no there is no silver bullet, I would say, for the number of hidden layers. It usually depends on the application. You have to check upon what suits your application, suits your problem the easiest, the best. Typically, you want to work the simplest model that gives you the best result. So that's the way you look at. Okay. Can I use ML in chemical engineering process? Actually, yes, you can use ML in chemicals. So this question came from Pandyan Shantakumar. So I'll give you a brief insight of what I did. So I was in the semiconductor. So I started my career in the semiconductor industry, where I made ICs, and I was interacting with the factory. So the factory, a semiconductor factory, is basically a chemical factory, and the chip making process finally is the manufacturing process is actually a chemical process. And I was actually working at analyzing the problems in making chips, largely chemical processes, and the impact it would have on electrical circuits. So yes, there are applications of there are huge applications depending upon the industry you are in, depending on the way you're using in a chemical plant. It is very important. CloudxLab is two or more hidden layers in yes. So my channel ask, is two or more hidden layers considered as deep learning? Yes, it is actually. Anything more than one is considered to be deep learning. That's like a simple yeah, that's like a empirical degradation. So Subodh Lonkar says increasing layers might lead to vanishing gradient problem. Yes, that's Subodh, that's correct. It's really nice to have such great questions and great answers. So yes, access. So what Subodh has said is a very much more technical answer. So one of the problems with increasing the number of layers very large is that in the end, what you need to do is you want to find the values of each of this weight, and you make this larger and larger, you come across a lot of problems. So one of the problems is vanishing gradients problem, or sometimes exploding gradients problem, due to which you can never solve the equation. So arbitrary. So yeah, so Subodh is absolutely right. Increasing layers can lead to a vanishing gradient problem. The Arush 15A answers that the algo used for instance-based learning is K nearest algorithm. That is an example. Yes, Arush is right. And my channel again asks CloudxLab, is there a rule to choose for the number of hidden layers? Again, as I said, there is no real rule. You have to choose based on your problem, and it's your understanding of the problem. So we will, as you go through the course, you will start learning how there are different architectures of deep neural networks used for different problems. Like for example, something that's used to solve something like trying to figure out the price of a car based upon multiple variables will have a completely different set of models, a totally different set of hidden layers, as compared to an algorithm that tries to figure out whether you have a cat or a dog in a picture. It's completely different. The architectures are different, the number of layers are different. So again, the architecture, the number of hidden layers, the weights of the models, all depends upon the problem you're having. Okay. Okay, Dinesh asks, I found your channel just now. Can I get information of Amal, which you were sharing in the past? Because I'm a beginner. Dinesh, you can go through our website. We have a bunch of information that is available for free. You can sign up with some of our easier courses to start with. If you just sign up in the form, you will get the slides and this video, a recording of this video later for your perusal at your time. Ashish Gupta, can the timing be made 1 hour early? Ashish, that is difficult. We've been iterating over a period of time of finding the best time suitable for everyone. So we've get people from all parts of the world, and it just turns out that 8 to 11 slot is the most optimum solution for most people. So again, as I said, if you're a part of a course, you'll get access to the videos. So if you miss a few lectures or miss hours of few lectures, you can still catch up by watching the videos. Okay, so as I said, a lot of people, everybody's using machine learning, almost everyone. There are a lot of examples. There's a TensorFlow demo at Playground, TensorFlow.org. Again, I'll share the slides. Please go ahead, check it. Now, there are a lot of deep learning frameworks that are available. TensorFlow, Theano, Keras, Cafe, Torch. So we would be focusing on TensorFlow and Keras. Well, specifically, we're using TensorFlow 2. In the TensorFlow 2, the Keras API is available in TensorFlow 2. It makes it just a lot more easier to make these deep neural network based models if you're using Keras. And so that is unique about our course as compared to the currently available recorded courses. We're using TensorFlow 2 with Keras. The previous courses use just TensorFlow 1. There are other machine learning frameworks which are interesting. One is Apache Spark, which is basically Apache Spark MLlib, which is useful for distributed ML. If you're learning, if you're using smaller data sets, then you could use scikit-learn, NumPy, or Pandas. If you're in smaller machines, so if your data set is small enough and it can be taken at one shot in your computer, so like if your computer RAM is smaller than computer RAM, then you can use these packages to run machine learning. So yeah, so I think next one section, okay, optimization of, okay, there's a question on Jaspreet Bhatia. Optimization of deep learning neural networks depends on which factors. Jaspreet, the entire act of identifying these the weights. So what is training is essentially, just go back. I think there's a few more questions here. This was like a simplest example at, like, say, one neuron level. So each this what you notice here. So this is like a knob, and the knob has inputs from all its input layer has inputs from all the previous layers, and each of the inputs is being multiplied by a certain weight. Okay, so the weight here, so in terms of the knob, the weight is how much is it towards the hot water or how much is closer to the cold water. That is the weight in this particular equation. Okay, so in in deep learning, what we are trying to do is we are trying to find these weights for all these knobs. So what is done is there's a whole step called training. What's done is that all these knobs, these weights are getting adjusted constantly. And so what's done is that it's just be adjusted constantly till you get closest to the answers you want. So that's the entire process of training. Okay, so next question, Indranil, what will be the latest cutoff for being present in the closed group session for the next session? So the cutoff should be somewhere next week. It should be around Thursday, worst case. So if you want to do, you'll have to sign up and sign up for the entire course before Thursday. And please know that we have a limit. So if you beyond a limit, then we won't be taking, and we're pretty close to it right now. Dinesh S asks, is deep learning approaching computational limits? Dinesh, no, not really. So what is really blowing right now is the applications of deep learning. So deep learning as a field, for its for its real applications, is not very old. It's just over 10 years old or something. Not much. As a field where it became application. And what has happened, it just became possible to do deep learning, because for what you need for deep learning is you need lots of computational resources, which is, and as you know, computations is becoming cheaper. You just have more and more of it available at a lower price. And the next thing you need is that huge amounts of data. So those two things are like getting more and more easily available now. What we have is we have increasing amounts of data, and we have ever decreasing price of hardware of computation. As you notice, your price of your mobile phones, or what you could get say 10 years ago, to the kind of mobile phones you can get today, you know what kind of prices are happening. We can, at least for a few more years, you can see that hardware will keep getting cheaper. We'll start figuring out better ways of, and better architectures of deep neural networks. So I don't think we are anywhere close to the to the computational limits. You will get this. Okay. Fine. Okay. Now we are. Okay, we are talking. We have a few more slides on computer vision. So one of the big, very interesting things that are happening today is computer vision. So vision is something which humans can do very easily. So one nice example is that, so in 1996, IBM's Deep Blue could beat Garry Kasparov, the then champion at chess, in 1996. But that computer could not look at a puppy and say, hey, this is a puppy. But probably a 2-year-old or a 1-year-old could recognize a puppy. Okay, so there were certain tasks that humans just could do much easily. And it's only like fairly recent that computers are reaching to a point where they can do a bunch of computer vision tasks. And that's one of the reasons why this is blowing up like so fast, where you're seeing basic computer vision appearing on very simple things. Even the smallest of web cameras today can detect faces, etc. So you're seeing proliferation of computer vision everywhere. Okay, so computer vision technology is kind of bettering our lives, as I said, as was here. So there are lots of applications of computer vision across a lot of places: mathematics, psychology, biology, physics, engineering, computer science. It's just and so it's really exploding right now. So it just becomes feasible. So computer vision became possible, and suddenly people are realizing, hey, I can get the computer to do so much more and I can take the people out of the equation. I can actually, by putting the computer there for tasks which were usually required people, the computer is able to perform better. Okay, I'll just finish this section and then I'll come back to question. Okay, now for an example, the ImageNet is a classification challenge, an open classification challenge. There are 1,000 object classes and over 1 million images. And a lot of these object classes can be quite subtle. The differences can be quite subtle. There could be like types of puppies, etc., which may not be even obvious to the human eye. And this is how the ImageNet has been progressing. Okay, so this is to show the explosion of why it's just becoming easier. So in 2010, okay, so this I'm not gonna. So okay, in 2010, so what we are showing right now is the errors on ImageNet. Okay, so in 2010, the best known model got 28% of the predictions wrong. So if it made 100 predictions, you give it 100 images, 28 of them would be wrong. and over a period of time, it's just been coming down and down. So on this ImageNet set, so I'm not going to talk about what is exactly the error, what is the exact error metric, but the metric I've taken, like percentage, is approximately similar to it. So the human error on that data set was estimated to be around 3.6. In 2015, the machines were beating it. So over large data sets, not over large data sets, machines started getting better at it. So 2015, the resonant model, this was a major. So what's happening is right now we've just got to a place where computers can do better computer vision at scale better than humans. Okay, so right now what's happened is that a lot of the newer models which I'm seeing is not trying to push this much further on. They say, hey, this is really quite good. What they're trying to do is they're trying to figure out how to make the model smaller and easier to compile. That's become a bigger challenge for a lot of the researchers today, as opposed to making a better model, because we've come to a point where we can do a lot of nice things with computer vision. Okay, that's okay. This is the end of it. Again, I have the list here. You can go check the course. You can enroll there. There are other courses that are also available. Please take your time and go through there. What I'm going to do is I'm going to go after. I'm going to answer a few more questions. We've got about 10-15 minutes, so I'll answer a few more questions. There's been some questions about how do we calculate weights of the neurons. Okay, so I think that's that's a very relevant question, and that's the entire that's like the core of what that's the core of it. So as I said, so the process of calculating these values of these weights is called backpropagation. So one way of doing it is, what you start is that you start it is, you say initialize the values with something. It could be it could be 1 or something. You'll just initialize certain values, and then you will run your input set on it, and you will get an output, and then you will compare that output with your known output, and typically there will be an error in it. Okay, so it's going to be wrong. So what you're going to do, then what's done is that there's a step where they identify the sensitivity of each weight to the output, and then what you decide is that, okay, I want to move the output is very wrong or slightly wrong, etc., and depending upon the relationship you'll move the weight slightly, and then you will run this iterative process again, and every time you run the process you look at the error and then decide which ways to change how much. Now this is done by a process called gradient descent and backpropagation, which is covered in the course in detail. Okay, that is it. Okay, Ketan Bhatt was correct. So again, it's very nice to have such. So Ketan Bhatt has answered that has answered correctly that the error rate is called the top 5 error rate here. So top 5 error rate is that so if you're given if you're given an image, the computer vision algorithm spits out a few options, and if the correct option is not in the top 5, it's an error. So that's the top 5 error, and that's the metric used here. So Ketan, you're absolutely correct. Fabulous, thank you. Jaspreet Bhatia says, when we say that there are 300 layers but we want to decrease the number of those hidden layers, are there any optimization involved? So are there any optimization techniques? Yes, there are optimization techniques. So these are what so a lot of the model builders build, and this is what like somebody who understands the problem, he keeps playing around, he or she plays around with it and tries to identify sensitivity to different layers. So what is done often is so what I showed you was like a simple, it's called a flat linear, a flat a flat DNN, where all the input, where all the all the neurons are connected to previous neurons, but there are new structures which does not connect all of them. They'll do certain, they will build different configurations, etc., and different methods. They will try to bypass some sets, etc. So a lot of techniques are involved. So there are a lot of optimization techniques that are used, and they'll be covered in more detail in the deep neural network, in the deep learning component. Okay, again, I am at the perceptron slide. How late can I join a session from the next closed group session without being marked absent? I don't think we keep. This is largely a course. Well, we don't run this course like a college class. So we're slightly flexible. So if you come in time, we consider you to be inside. So these courses are. We assume that you are responsible adults who will take care of time. So if you just come in and sign it at any time, we typically give you credit for attending that class. Okay, can you? So algo depends on the. So there's a bunch of questions on training. Yes, that is the core of it, and at some ways, like this is like the easiest example of it, where again, where you have each neuron is a knob, and these are the previous layers, and this is your. So this is like a very simple, a single layer, a single neuron, ANN. So what you're doing is, again, just understand me. So when you start, you will start with, say, a very hot water, and so when you come in, you'll come in. You probably initialize in the middle. Okay, that's one of the golden rules. You enter a hotel room you have never been into. You will come and you will put the knob exactly in the middle, and you will see what the combination of hot and cold water are giving you. So you know internally that this is the temperature you are comfortable with. So you know the right temperature. And if the temperature is too hot, what would you do? You would move this towards cold. Now if the temperature was too hot, what would you do? You would move it faster towards cold water. You would take a bigger step. Okay. And then if it becomes too cold, what would you do? You would slightly move it towards hot. And so again, and then you would compare the temperature then, and you would eventually come to a point which you are, say, comfortable with. So that's the answer. So now what you have is, you have specified the weight, you've specified the amount of hot water you need and amount of cold water you need for the temperature you want. Okay, so this is an example of what this is training. What you have done here is trained. You have trained this neuron to give you the optimum temperature. So what is done in deep neural networks is, you do the same thing. You just do it at scale. You do scale with like 1,000,000 neurons, or more than that actually. You do the 1,000,000 neurons with a lot of connections. That's what's being done. Is it similar to Monte Carlo simulations with random paths? Actually, there's an easy example is to try to look at Newton-Raphson's, but Monte Carlo simulations is a way of looking at it. How do increasing the number of okay, there are a bunch of questions. I'll just go through. Can we train a model to manage a security system? Shantanu Bhattacharya asks. Yeah, no reason why you can't. With the right amount of data and the right correct model, you should be able to train it. Is Python different than C++ for AI development? Yes, it's a different language. I think Python is actually a lot easier than C++ to operate with. So if you are really comfortable with C++, Python will be a lot easier. Arush, that's question from Arush 15A. Jishnu Bhatt says, does robos use artificial intelligence? The newer robots are using artificial intelligence. So more and more of them are using artificial intelligence. If you want the robots to see, for example, you'll have to give it a certain number of computer vision. If you want the robots to understand what you're saying, you'll have to have a certain number of NLP. So, etc. Dhruv Mishra says, increase the number of layers is directly proportional to accurate prediction. Not really. So at some ways, Dhruv, it's right. As we increase the number of layers, so as we increase the number of layers for very complex problems which have lots of data, we see usage. But in general, you can't just say just randomly increase the number of neurons, and there would be that this would increase. That's not right. Okay. Okay, so we are kind of coming close to it. We will, Jasprit Bhatia, we wanted the standard self-paced books. We will share the information we have right now with us. Uh, if that's it, I guess. So I had a wonderful session talking with you guys. Are there any questions? In the case, we'll be wrapping up then. Okay, guys. Thank you for your time. This is a great Sunday. I enjoyed talking with you. There were a fabulous set of questions. Okay, some more questions. Are there AI frameworks using Java? Yes, there are AI frameworks using Java. Actually, even TensorFlow, etc., have Java-based APIs. As machine learning depends on data. Okay, so a lot of the questions. So there we have, as I mentioned on our website, we have a forum. So you can use the forum to ask us more questions. We would love to answer your questions. Please let the questions flow. If you're a member of our course, then you would get another chance to interact with us next week and for a much longer time. Questions on GRNNs, which we will talk later. We will share the reference books. Job assistance, as we said, we have job assistance. It's on our website. We connect you with with our partners who will help you get jobs. We don't assure you, but we try to improve your chances as much as possible. Okay. Thank you. Thanks for your feedback. We have also shared. Yeah. Yeah. So please don't forget to register with the form which we have shared, and so that we get a chance to share the slides and the video with you. Thank you. Thanks for your time. Okay. There's a question on DevOps. I'll just answer this one. We have a small section on DevOps. We don't do DevOps in very detail in our course. We have a separate course that tackles DevOps in more detail. So that could be of interest to you. Okay, guys. Thank you. Thanks for your time. This is great. We'd love to do it again. Thank you. Bye.